We take a look, we're looking at lesson 6.8, the standard form equation of a line. This is just another form for the equation of a line. It is used to describe a line for several different reasons. It's most often pops up if we're talking about a combination pattern. What is the standard form? Ax plus by equals c, where a, b, and c are integer constants, and by integer we mean that there's no fractions or decimal parts involved. Typically a is not negative. That's not something that I'm going to be too hard on you about right now, but typically a is not a negative integer. Couple of examples. These are all examples of standard form equations where the x and y terms are both on the left side of the equation. The x term comes first. The middle one looks a little bit goofy, but really remember that minus as though it is a plus negative, so we're okay with that one. Here are a couple of non-examples. As you can see, we've got some fraction parts. We've got x and y not on the same side. Here we've got some decimals. We've got all sorts of goofy stuff going on here in our non-examples. So this is standard form. As we take a look, we've got something called combination equations. Take a moment to read through this example about paper football. As we take a look at this example about paper football, we've got some sort of a combination here. We've got 6 points for a touchdown and 3 points for a field goal. We've got some sort of combination of touchdowns and field goals giving us a total of 18 points. Our job is to write an equation that describes the relationship. So we've got some combination of touchdown points and field goal points that adds up to 18. We know that touchdowns are worth 6 points apiece and field goals are worth 3 points apiece. So we can say 6x, 6 times the number of touchdowns, plus 3y, 3 times the number of field goals equals 18. Here we have an equation written in standard form. Another combination one that we might see. Steven's earning money by doing odd jobs around the neighborhood. $20 for each lawn that he mows, $15 if he rakes the grass clippings for a yard. If he earned $240 last month, we want to write an equation that describes the relationship of x, the number of lawns mowed, and y, the number of lawns raked. Here we would add our mowing money plus our raking money to get a total of $240. So thinking about what we did in the last example, we can use x and y to describe the mowing money and the raking money as 20x plus 15y equals $240. Like any other equation with an x and y variable, these can be graphed. They would be graphed in a linear pattern. If we want to write an existing equation like the ones that we had in standard form, it depends on the form of the equation. A few of the characteristics that we have to make sure are happening, that x and the y terms are both on the left side, in that order, x first and then y. There are no fractions. Multiply both sides by a common denominator if necessary to get rid of them. And there are no decimal parts. We would multiply by tens or powers of tens on both sides to clear those decimals. So right now we're going to see a conversion for each of the non-examples that we saw in the very first slide. Do you have to write them all down? Not necessarily, but you should have the know-how of how to complete each one. So at this point, if you don't want to write them all down, that is absolutely your choice. However, you will need to know how to complete something similar when we take a look at the assignment. So if you're not sure why something happened the way it did, please feel free to write that one down and ask about it in class next time I see you. So let's take a look. This equation is not in standard form because we've got fraction parts. How do we clear out the fractions? Just like we learned way back when, I believe in chapter 3, we can multiply both sides by a common denominator. When I look at my two fractions, my denominators are, of course, a 2 and a 4. Common denominator here would be 4. So we will clear fractions by multiplying both sides by a common denominator. Multiplying by both sides by a 4, we would, of course, have to distribute that multiplication on the left side. Just simplifying out here, we would come up with 2x plus 12y equals 1. The simplifying happens really nicely here. The 4 and the 2 the 4 and the 1/2 simplify down to be just the 2, and then the 4 and the 1/4 simplify down to be just a 1 with our 4 and 4 here. We've got both our x and y on the same side. There are no fractions. X is first. We're good to go. Taking a look at this equation that is not written in standard form, obviously we can see that the x term should be first. So taking a look here, this is an okay-ish standard form, negative 3x plus 4y equals 9. Typically, we don't love to have that coefficient on the x being a negative. So what we would maybe take a look at is doing the opposite of each term. 3x plus negative 4y equals negative 9. Essentially, what we've done is multiply through by negative 1. This equation is also not written in standard form. As we take a look here, we do have that ugly decimal coefficient on our y term here. So we actually need to multiply by a 10, 100, 1,000, so on, any power of 10. In this case, we actually need to multiply by 100 since we have 2 decimal places to clear out. Of course, we'll need to distribute here on the left side. If we simplify, this says 500x plus 452y equals 2,000. Standard form, we've got x and y terms on the same side. The x term is first, and in this case, it is in fact a positive on the x term, which is exciting. This one here, we've got a lot of issues going on. We can all see the fraction, which is not a part of our standard form. We also are noticing, I hope, that the x and y term are not on the left side of the equation. So first things first, let's clear out that fraction by multiplying by a common denominator of 3, being the only denominator. Simplify using our distributive property. As we take a look here, we come up with 3y equals 4x minus 18. Now it's time, since the fraction is cleared, for us to deal with this x and y being on opposite sides of the equation. So using addition, we can add negative 4x to both sides. This is what we see. Ideally, that first x term is a positive, so if we do the opposite of each term, our final standard form here is 4x plus negative 3y equals 18. So again, you are responsible for kind of having some know-how with each of these. I would expect, if you did not understand how one of these procedures happened, that we can talk about it next time I see you in class. See you then.